So, ladies and gentlemen, a very warm welcome to all of you. It's my pleasure to have you here this afternoon. Welcome to this Neptunus Asset Reliability Management webinar on 5 ways to save big on your 4-stroke diesel engines. So before I start, just a few pointers to make this a good seamless experience. First of all, on the bottom of your screen, you'll see a magnifying glass with a plus and a minus there. I would request you to use that to adjust the size of the display on your screen so that you can get the entire presentation properly listed on your screen. All of you have been put on mute. This is to prevent background noises so that everybody has a good listening experience. Also put your mobile phones on mute just in case you don't want to be disturbed. I'll stop at the end of every section. We'll take a few questions. Please use the chat box to communicate. Zoho is a very safe platform. We've chosen it because of security concerns that could be there on other platforms. If you do get a lag between your audio and visual, I would recommend that you refresh your screen to get rid of this lag. At the end of the seminar, please do not close your browser to leave. Please press the exit or end button in the bottom left of your screen. This will get you onto a feedback form. Last time we had 71% of the participants who gave their feedback. Those feedbacks are essential for us to keep going. So please take that minute or so. I'm hoping to get 100% feedback this time. Once again, zoom in, zoom out in case you need to adjust the presentation on your screen. And one last thing, Zoho, one of the glitches that we've seen in Zoho is my camera goes off by itself every few minutes at times. Please don't get distracted because you still see the presentation on the screen. I'll try and come back as much as possible. So enjoy this afternoon. We've got a 45-minute session. I'll try and keep it to 45 minutes. So COVID-19, ladies and gentlemen, is going to place a big premium on cutting waste. So the question is not cutting cost, it is a question of cutting waste. And this seminar was inspired by a few queries that we got from our customers saying that they wanted us to reduce the cost of our spares and services because of the hardships, etc. And that brought me to one principal question that I've always tried to deal with is, how do you cut waste and how do you place a premium on cutting waste rather than cutting costs? So this seminar is a result of that. I hope by the end of this session, we have a clear idea of how to save money. In my mind, reducing 20, 25, 30% on OPEX costs should be possible without, in any case, compromising on reliability. So here we go. What are the 5 things that you can expect from this webinar today? So some tips on spare part management practices. We are going to also talk about fuel management to reduce wear and tear. Basically, how do you take care of water and cat fines? I'll come to lube oil condition monitoring and lube oil as the key to increase the mean time between overhauls. I'm going to also talk about torsional vibrations as the exciting new technology to prevent failures. And how remote monitoring has become today. So we'll talk a little bit about old world practices, we'll talk a little bit about common sense, and we'll talk about cutting edge technology. We'll try and bring all these together to see how we could achieve these considerable cost savings and increase in reliability of your engines. So the failure curve, all of us are familiar with it. But very quickly to take you back, the black circle on the failure curve is where your engine will fail left to itself without any maintenance. So as time goes by, engine performance deteriorates, and you start getting to a failure point. Ladies and gentlemen, once again, if you can't see my screen, please adjust the plus and minus buttons on the bottom of your screen to fit it in. Instruments fitted on the engine by the engine manufacturer usually give you a limited time period for action before failure occurs, and that is the red dot you see on the failure curve. These are more audio-visual maintenance practices, somebody hearing sound, somebody having a feel, somebody noticing vibrations, somebody seeing temperatures are high, somebody seeing pressures are low, etc. And so that brought some other condition monitoring equipment like lateral vibrations. Somebody talked of diesel doctor. Somebody talked of lube oil analysis, etc., which took your detection point further up the curve, what you can see on the brown one. What I am propagating to you today is to move it so far ahead on the curve that you have enough time to take small corrective steps, small continual improvement steps to keep your engine performing in the best bandwidth. So I call that detecting cancer at stage 0, which gives you enough time to take corrective action and eventually eliminate breakdown completely. So look at the previous slide. If you see the typical cycle of overalls, you will see that the red line is what your OEM recommends. So after a certain number of hours, he could ask you to do a top overall, another few hours a major overall. Performance goes up to close to what it was at the test bench, comes down again, and so on and so forth. The dotted line below that is the line that an operator would typically do. So try and extend overalls even at the cost of performance. And the blue line on top is what we propose is the right method of maintaining equipment today. So small steps. So if one fuel injector is bad, replace it on time before it creates more problems in that cylinder. If there is one cylinder which has poor compression, please take care of that before that becomes into a bigger issue. Eventually, I want to see this industry moving away from top overalls and major overalls to a system where we are going to say that we'll do whatever maintenance is required at frequent intervals to keep this within a band range. There is a lot of research work going on here. The numbers that researchers have put out for such an approach to maintenance is staggering. They're talking of 70 and 80% reduction in OPEX costs by doing maintenance in this manner. So more of it later, but it's something that I'd want you to think about. Let's come to spare part management. Spare part, most expensive element of OPEX other than fuel. So I'll place before you a few pointers. Please see what you'd like to take away from this one. It would vary from ship to ship or from company to company. But essentially, what we observe over the last 20 years or 25 years, that common sense has been replaced by a repair and replacement philosophy. So at one time, overalls meant you had micrometers, you had verniers, you had internal micrometers. Gauging was such an important part. And after all, a top overall is nothing but a decarb, what we call. That means removing carbon from the cylinder. Do you really need to replace cylinder heads? Do you need to replace all valves? Do you replace all guides? Do you need to even change turbochargers? Is it not possible to overhaul it? So I rarely see these days people gauging cylinder liners in four-stroke engines, especially the high-speed engines. I rarely see people gauging valves or valve guides, etc. A lot of money, I believe, is being wasted. So maybe you want to look at going back to what we did 20 years ago. That means that you calibrate, gauge, and only change those parts which have gone outside their wear limits. Incidentally, Caterpillar, Cummins, MTO, all the high-speed guys, even now if you ask for it, they have a manual that will give you change or wear limits, and they will tell you which are the use again limits. So try and use that as one step. Reman parts, I think all those who use CAT or Cummins or MTO engines, high-speed engines especially, reman parts or remanufactured parts is a great way to save money. Are they genuine? Yes, they are genuine. Are they rebuilt at the factory or by a distributor? The answer is at the factory. They carry the same warranty as brand new parts. Big savings. For example, on your CAT 3500 series, an injector is roughly $1,800 to $2,000. A reman part will cost you roughly $1,200, a clean saving of $800 per injector. If you have 16 injectors, we're talking of saving $12,000. It's a lot of money. So cylinder heads, turbochargers, lifters, all sorts of components can or could be looked at under the reman program. Please see if you're using them. That's something that can be saved very easily. Plan in advance. Get discounts from your vendors. Most manufacturers, if you place orders for your overall 6 months in advance, would give you decent discounts. Nigata, for example, would give you anywhere between 2 and 7, 8% for bulk orders that are placed 6 months in advance. I think all it needs is a little bit of planning, and 7 or 8% discounts are not small. So please speak to your vendor, see if there's a solution that you can find. Okay, so you've ordered spare parts. They've come on board. You've done a full overhaul. Now, have you ever wondered what happens to the balance parts? So it's impossible that somebody has ordered just the exact amount of parts that go into an overhaul. The bigger the overhaul, the larger is what I call as the spillover. It is our estimate that anywhere between 2 and 10% of the parts are either left over due to excess or wrong ordering. So if the parts are wrongly ordered, what happens? They get lost into your system. They get stored on the vessel. Nobody ever hears of it. The office doesn't bother to find out what has happened to these excess parts. The next chief engineer who comes in here is unsure. They may not be stored properly. They could be rusted. Lot of money, I believe, goes wasted here. Please focus your attention to whether you are taking care of those parts that are balanced after an overhaul. Ladies, gentlemen, you could address your questions into the question box on your left there. I'll take a few questions after the next few slides. And finally, is a centralized inventory management possible? So it is possible that you may not have a central store, but in today's technology-driven world, it is completely possible to account for the last O-ring or gasket within your fleet, especially if you know that you have a number of engines of the same type. So eventually, these 2 and 10% that are actually located in various parts of your fleet should be tracked and should be available for an overhaul on another vessel. So, centralized inventory management, make it possible, money to be saved. I've got a few questions here on. Do I have any questions here? So I believe makers take back leftover spares at lesser price. Sunil Kumar says, Sunil, I don't know whether they take it at a lesser price, but if you could negotiate with them earlier, or if you could negotiate with them much before the contract starts, I believe there is a chance that you could get them back at the same price. Ravindra Pandey asks, is the Gata engine spare parts available reman? At the moment, we don't have a reman policy, but in any case, our being a medium speed engine, the spare part consumption is very small. Bhagyashree Ogle says, could you please clarify what is MTBO? Sorry, Bhagyashree, MTBO is mean time between overalls. So the period of time, either in running hours or in case of cars, it could be mileage, is the time between two overalls. And the whole idea is that you want to extend the time between overalls. Is there any drawback in using reman parts? Hitesh, none at all. There are no drawbacks. Reman parts carry the same warranty as original parts. What is the life of reman parts compared to new parts? Mr. Bhutapuri asked me. It's the same. It's absolutely the same. There is no change because it's only the casing that is being reused. All other internal parts are brand new. So please do not believe that reman parts would have a lesser life. And this goes across brands. I'm not only talking of Cat or Cummins, but across brands. Okay, let me move on to the next question, next section. So I'll talk a little bit about fuel and lube oil together, and then we'll take questions at the end of that session. Lot has been said about 2020. Lot has been said about all the issues that were going in here. My target audience today is really the OSVs, tugboats, drilling rigs, etc. And most Indian operators whom I speak to are not facing too much problems with injection equipment due to usage of low sulfur fuel. What remains a concern is water and cat fines. Water in modern diesel engine injection systems, even in small quantities, is extremely detrimental. One, it starts causing micro degradation at the surface level. That means that the tight tolerances on fuel injection equipment are very easily lost. And it could mean damaging your equipment completely. A recent case, one of our customers' assets had water ingress into his service tank. Within 6 hours, every single injector on two of his engines had to be changed, replaced. Very expensive lesson to get water out of the system. So what can you do? Depending on where you bunker and the quality of your bunkers, a simple water sensor on your bunkering line could be a good idea. And like I said earlier, I'm not here to tell you what to do, but I'll throw ideas on the table for you. Putting a water sensor in your service tank could be a good idea. But in any case, I'm a strong advocate of filtration. And online filters with water separators could be an absolute must in today's day and age. So research tells us that 6-micron filters are good to remove cat fines from fuel. So a good 5 or 6 micron filter, a good beta ratio of maybe 600 or so with a water separator online onto your engine. It costs maybe $2,000 or $3,000, but it can increase injection equipment life anywhere from 25 to 50%. It's a good investment. Good fuel injection equipment means a good combustion chamber, clean combustion chamber, and that means that automatically you're prolonging the life of your equipment. Lube oil is something I'm passionate about. We had a seminar recently. I keep spreading this message, not only in shipping, but also in industry, that the lowest hanging fruit that you could think of, the lowest hanging fruit to saving big money on your engine is to focus on your lubrication oil. And few people take it very seriously. But if you look at the diesel engine itself, oil degradation is caused due to products of combustion such as acid, soot, unburnt carbon, moisture, etc., getting into the crankcase. You have a reduction in viscosity due to fuel dilution, coolant dilution, sometimes chemical contamination. Oil is under attack due to carbon deposits and due to the millions of wear and tear abrasion particles that keep coming into the sump. These cause oxidation. We know oxidation is the nemesis of oil, and therefore the varnish, lacquer deposition, etc. Additives get depleted. The oil, the products of combustion are acidic. They come in. You have TBN being the base additives being attacked. Where additives being attacked, thermal degradation constantly happening. So it is no wonder that oil in a diesel engine tends to degrade very rapidly. And so those of you who attended the Lube Oil seminar, these were the 3 slides that I keep talking about. Please pay a little bit attention here. 90% of oil particles in your oil are below 5 micron. All your lube oil filters installed on your engine are 8 and 10 micron. That means that 90% of the particulate matter never goes through a filter or is never addressed by a filter. And these 90% of the particles is what really should worry you, simply because these are the particles that cause oxidation in the oil. Oxidation causes varnish and all the other issues that you face commonly with lube oil. The other thing that I want to highlight is how clean oil can dramatically improve the life of equipment. So if you look at this chart here, and if you see your oil condition on the ISO 4406 grade, improving from 1815 to 1714, it's a very small improvement from 1815 to 1714. Your life of equipment of hydraulics and diesel engines increases by a factor of 30%. Just a very small, and that's why I call it the low-hanging fruit. A small increase in cleanliness levels can have a dramatic increase in the life of your engine components. And the same thing with water. Water, number one enemy in your oil. 2,500 ppm oil, water and oil, bring it down to 150 as an example, and what you have is a life extension factor of 5 times. If you have 250 ppm, bringing it down to 33 ppm will give you a 3 times life extension factor of your components. So please treat your oil with great seriousness. So how do you prevent oil degradation in diesel engines? 2 common things, of course: prevent contamination, have a great combustion chamber. But what I propose is offline kidney loop filtration systems. That means have a offline system that is doing only sump to sump and monitor the condition of your oil. Please consider using bypass kidney loop filtration systems. These need to be independent systems that run 24/7. They are fractional horsepower pumps. The flow rates are typically 1 to 2 liters per minute. Make sure that your filters have a high beta ratio of at least 400 plus. Ensure that the oil has at least 2 passes a day. To get your oil down from 1815 to 1714 or even better is a question of a few weeks. The result you will see is in a cleaner combustion chamber, a cleaner crankcase. 6 months down the line, the crankcase looks as if it's out of a brand new engine. Oil life can be extended by 300 to 500%. We've got enough data on ground to help you to take a decision. Payback for these filtration systems, in my mind, is less than 5 or 6 months. And that is the direct payback. When we are talking direct payback, we are talking of what you save in terms of oil and lube oil. We are not counting what you save in terms of increased life of components. And of course, if you want to monitor your oil, if you want to keep the quality high, you need to monitor it. If you do not believe in real-time monitoring, at least have regular lab tests done. Today, real-time monitoring is so cheap. For under $2,000 or thereabouts, you could get a single sensor that could detect over 22 failure modes, give you real-time rate of oil deterioration. It could tell you, it could trigger alarms in case of sudden contamination of oil. It could almost eliminate the need for you to send lab analysis, samples for lab analysis. And of course, it gives the power back in the hands of the operator. So these are some of the things that an online sensor can do. Our field experience, online sensors can give you an accurate condition of your oil. In some cases, it could prevent you from changing oil at intervals specified by OEM by a factor of 50 to 100%. In case of contamination, it could prevent catastrophic failures by giving you early alarms. A combination of online sensors and offline filters, I can guarantee you your oil life will increase by a factor of anywhere between 2 to 5 times. Payback is less than 6 to 8 months. The direct savings is savings in lube oil and filters. The indirect saving is, of course, the bigger one, which is the longer life of engine components. So once again, lowest hanging fruit, oil. Please take oil management very seriously. Before I move on to torsional vibrations, are there any questions there? So, cause of asphaltenes and damage in lube oil, even though filters are in place. Cause of asphalt, I don't understand this question. Cause of asphaltenes and damages in lube oil, even though filters are in place. So if you are looking at filters which are installed on the engine at 8 or 10 microns, there are hardly any, they're really not doing the work that they're supposed to do. Look at offline filtration systems, which typically you could start off with maybe 5 microns, later on move to 3 microns. They will not only remove wear particles, effectively stop oxidation, but to a large extent, they could remove sludge, carbon deposits, etc. Please keep in mind that the color of your oil cannot change because the soot actually discolors the oil. So the color of your oil is really not any measure of how clean or dirty it is. I've got a question. What is the high beta ratio for lube oil filters? A high beta ratio for lube oil filters, I would think a minimum of 400. Some of the good filters could go up to 900,000, but 400 I think should be minimum. I've got a question. Is bypass system a portable one? If you have 5 engines, can one system suffice? Difficult question. In my mind, no. In my mind, please install one fixed system per engine. A, you want to prevent contamination between sumps. And B, the whole idea is to have a system which is working 24/7 and which gives you the best possible results. Like I said, even on one engine, the payback is very quick. The moment you get into portable systems, now you're depending on crew to make sure that they diligently plug it, unplug it. You are dependent on people now to make sure that this is not lying in your store for days together. And essentially, you want to remove most of the dirt load from your oil when the system is at rest. So 24/7 is something I'd like to do. Do class recognize real-time monitoring systems? The answer is class does recognize real-time monitoring systems. The subject is relatively new. All classification societies have it in their rules that they will recognize systems. What you'll have to do is to install a system, run it parallelly with your existing system, work with class, give them the confidence that the data is reliable and consistent. And yes, your answer is they will accept it. Can these filters be fitted to on MAN engines? These filters can be fitted on any engine. So I'm not talking of A or B or C make of engines. The rule applies to any engine, offline filtration systems. How effective offline filters? Is that cost effective? So let me try and put some numbers for you. Let me take a cat engine which has a 35 series engine, sump maybe 800 liters, oil change every 1,000 hours. So I'm saying that the effective cost of an oil change could be $2 a liter, maybe more, but conservatively, let's say $2, and this includes transportation, etc. If you could double your oil life from 1,000 to 2,000 hours, you have saved $1,600. An offline filtration system, in my mind, roughly is give or take $2,500. So we are talking of a very simple system that can pay back in less than 2 oil changes. Online sensor results are acceptable by OEM. They will probably ask for records. I don't see how the OEM is concerned with your oil records. OEM never asks you for your oil records outside warranty. So while you are in warranty, please observe all the rules that the OEM wants. Beyond warranty, these are systems that you are installing to enhance the quality and the life of your equipment. Thank you, sir. Could you please share if Neptunus does install these real-time lube oil monitoring sensors? We do, but we won't answer that question here. Ideally, we would wish to know where the water filters are to be fitted in line. So, Simran, the water filters are, so these are composite filters. So they are fuel oil filters combined with water separators, and you could fit them anywhere in the system between your service tank and your fuel pump on the engine. Okay, I think we're a little short of time. Let me go on to torsional vibrations, which I think is what is the latest technology that is emerging. So I started talking of torsional vibrations and the beauty and simplicity of this system maybe 2.5 years ago. I made some presentations to a lot of classification societies. The concept then was new to understand. Even today, people cannot understand how a single RPM measuring sensor, a magnetic pickup unit, can give you such detailed diagnosis. But you'd be happy to note that recently there was a press release from DNVGL saying that they are now using torsional vibrations to monitor the condition of bearings and shaft propulsion systems. So it won't be long before there are other people who start picking onto this technology. Essentially, torsional vibration is understanding the movement of the shaft and picking up the variations in the shaft rotation and to connect it to faults in the cylinder. We are not talking of the RPM varying. So the RPM in a diesel engine will vary. If it's a 1500 RPM, it could be anywhere between 1470, 505, etc. I'm saying that within a single rotation of the shaft, the changes in the shaft and the change in the position of the center of the shaft with respect to the axis is what torsional vibrations is. So, what are the current methods being employed to predict faults. So currently, there is no reliable system in the market to predict faults. And predicting is different from pinpointing or troubleshooting. So it is one thing to have a broken cylinder or to have a piston ring that is worn out, and then to diagnose a worn piston ring, that is troubleshooting. It is not predicting a fault. When we say predicting a fault, could we now look at data to say that there is an imminent danger of the compression pressure in this cylinder deteriorating to a point where combustion could be affected? Or is there a way to say that there is sufficient stresses on this bearing to cause failure, which may happen if uncontrolled in the next 6 to 7 months? That is the difference between predicting and troubleshooting. Number one. Number two, OEMs depend upon pressures and temperatures and gauges that are fitted on the engine itself to tell you the condition of the engine. Again, they're telling you the current condition of the engine. They may be able to tell you that exhaust temperatures are rising and they are on the limit. If they go up too much, then if they go up too much, then your valves would fail, etc., etc. So those are present conditions. The next thing is there are certain models like Dr. Diesel, for example, but these require the cylinder pressure to be monitored. Now, peak pressure monitoring is not easy, even on two-stroke engines. At the best of time, it is a big circus. You're dealing with hot gases. Permanent sensors installed on the cylinder are extremely expensive. They are prone to failures, etc. So, not great. Ultrasonic measurement of components, very accurate, but it requires a very high degree of skill on part of the operator to take his ultrasonic measuring equipment, actually point it into the combustion chamber faults. So, and not great in using, not great in online monitoring. So, what is the option? Torsional vibrations is nothing but the measure and analysis of the speed and the analysis of its variations through statistical and mathematical computation to derive component-specific and overall health indicators. What do I need? I need two sensors. One is to measure, one is an MTBO that actually measures the speed on the flywheel. And I need another sensor anywhere on the engine which could reference my top dead sensor on one cylinder. That is because I need to actually pinpoint where exactly is my problem. So once again, retrofitting, simple, easy, one sensor, one TDC sensor, and this is what the theory is. So if I take any two-stroke engine or any four-stroke engine, if I know the number of cylinders, if I know the RPM, and if I know its firing order, I can create a theoretical sine wave which would be practically the same for any engine. So we know that the RPM is almost a sine wave. So whenever a cylinder fires, there's an instantaneous increase in RPM. When the speed, when it goes into compression mode, the speed drops, so on. So if you can see your graph here, signal A on the top left is the theoretical signal which is calculated on the basis of basic input data. Once again, ladies and gentlemen, if this screen does not fit in here, my presentation doesn't fit in here, please use the plus and minus to fit it into your screen. My speed measuring signal B gives me the measured signal. So the difference between A and B is a signal which I'm going to subject to Hilbert transform. Hilbert transform is a mathematical formula that is applied to this signal difference. And just like in accelerometers, I now have angular displacement, angular velocity, and angular acceleration. These are derived from velocity. Further, our IP now, where we get into computation of statistical moments. You get mean, skewness, variance, and kurtosis. These signals are also subject to harmonic studies. For example, here we've shown you that the first half of the sixth harmonic has a spike, which is related to the fuel injection equipment in your system. So there are indicators, half harmonics, that could connect to certain indicators on your system, and just one RPM sensor is able to give you this data. So it gives you the overall mechanical health of the engine. So if you were a fleet manager, the overall mechanical health and operating condition are the only two parameters that you need to know on your mobile. If these two are within normal limits, you needn't look at the rest of them. But going further, it can tell you what the mechanical stresses are. It could tell you the condition of the mounts. And this has nothing to do with the condition of your moving components within the engine. It could be external factors that are affecting your foundation bolts. This could be thrust from your propeller, thrust from your alternator. It could be a loose or bad foundation, etc. It also gives you a torsional angle or a twist, which is the difference in the power between the left bank and the right bank in V engines. Further, these two sensors can also give you the power output, very useful when you're talking of propulsion engines. Once again, just two sensors, easy to retrofit. And what are the cylinder-specific indicators? So currently, the system can give you about 4 different indicators. Cylinder-wise, it could give you the compression on a scale of 0 to 100. It could tell you the injection timing, again on a scale of 0 to 100. Injection condition, again on a scale of 0 to 100. And bearing and friction, again on a scale of 0 to 100. So this is the detailed information that is possible to get here. Now, for a moment, let's stop and look at compression. So essentially, we are following trends. If you see that the compression on, say, cylinder 4 is constant over a period of time, really there is no need to even open that injector. But if you see that there is a drop in the compression levels of that cylinder over a period of time, you may judge that, okay, it is coming to the end of its sequence lifespan, and therefore it could be an issue about weak piston rings or valves, etc. You may only want to do that particular unit and leave the rest behind. And so I said in the beginning that we would like to move away from top overall, major overall. I think using these indicators and the ones that I showed earlier on mechanical health, operating condition is nothing but the fuel efficiency of the equipment. It should be possible to start working on specific cylinders rather than opening the engine all at once. So once again, I'm coming back to the slide where I started off with on continual improvements for extended life. If we could take small corrective steps based on cylinder indicators, what we could do is start taking continual steps, small corrective actions. You're not letting the engine performance deteriorate to a level where large amounts of money are required to bring it back to its original condition, and you're keeping the engine within its with tight limits of performance. Ladies and gentlemen, please make sure that you may go on the net. There is a lot of material there to tell you how condition-based maintenance can save you tons of money. That is what I'm trying to propagate. Please move on to from time-based to a system which makes more sense in the long run. Let me sum up why torsional vibrations is so exciting. There's a considerable saving in fuel consumption, overall efficiency. There's cylinder-specific indications to pinpoint exact cause of trouble. You can extend overall interval safely. If you can take your 15,000 hour overall to say 20,000 hours safely on the basis of data, not on the basis of your chief engineer's gut feeling, purely on the basis of data, that's a clean 33% that you've saved there. If you start adding savings from lube oil, savings from fuel, savings from spare part management, I think there's a lot of waste in the system which you could focus on. Our eventual aim is to eliminate all breakdowns. We want to reduce operational and efficiency, downtime costs, and of course, we want an overall health indicator. Any questions so far? What does MTBO mean? MTBO means a magnetic pickup unit, an RPM sensor that you have installed on your engine. At what time intervals this torsional vibration measurements need to be taken? Mr. Krishnan, depends on how your engine is running, but a lot of people now want it to be permanently installed so that this is an online monitoring system. You can pull out the data maybe once every 2 hours, 3 hours or so. But these are all online systems that are meant to be installed permanently. The responsibility to use CBM in place of PMS is difficult to take in by big bosses of the company. Sanjeev, I don't know. I have no answer to that one. That it's difficult to take in by big bosses. But I do know several companies are moving towards CBM in place of PMS. It will require you to work with class to prove to them that you are doing it in a very scientific and methodical manner. Maybe you need to demonstrate that by keeping records and documents till they believe that your condition-based maintenance system is reliable. But class has already started approving certain processes and methods. So really, it's a question on when they do it. Is this change in overhauling running hours is accepted by class? Like I said, class has not put out rules. They have only said that condition-based monitoring, condition-based maintenance will be accepted. Like I said earlier, you will have to work with class to get it done. But finally, it is in your interest. So please don't leave it saying that class does not accept it. It really doesn't matter whether you spend X or 2X for anybody else. It's your money, your owner's money. So it's in your interest really to take those steps which will save money. So working with class, something that you have to do, and the rules permit it, you need to prove that your system is reliable. Sujan sir, good afternoon. Good to have you here. Is there a way to automatically trend the torsional vibration reports data by the system itself? Yes, now it is possible. In fact, a small HMI fitted next to the engine will give you the output without any human intervention. So this is a continuous processing, can be done, sir. Rupam says, does vibration analysis available in main engine? So Rupam, it is available for any engine, for any rotating equipment. We put it on large motors, we put it on roller mills, we put it on ball mills in cement plants, we put it on diesel engines. So yes, it's available for any rotating engine. Is the same installed MTBO will be used or new one? So if you allow, so you can use the same one, the same MTBO that is already installed on your engine. You don't need to put in a new one. Narendra Kumar Ramu, is condition-based maintenance applicable for all machinery? Absolutely. Yes, sir. Okay. So, remote monitoring. Is there a case now? Is there a case now for remote monitoring of your engines, either on rigs or on board vessels? At one time, remote monitoring was expensive. The whole process meant a lot of investment. But let me make an argument why remote monitoring is and should be considered. One, COVID is making it more difficult to get people on board your ships or rigs. Recently, we had to send 3 of our techies on board a rig. That meant that we had to send them 7-day quarantine in a hotel, testing before going on the rig. After you come back from the rig, another 7 days of quarantine, testing again, come back. Whoever bears the cost, it is a cost. So 14 days of idle time, testing, and that means that in an emergency, you can't get people ashore on board. So this is something that is going to stay with you. We better plan for it. Shortage of crew is already being felt by a lot of ship owners. Shortage of skilled crew is something that we've been complaining about a lot. And today, technology has become so cheap that anybody should be able to get whatever data you wish and need on your mobile devices as well. So you can get your entire engine details of whichever vessel you want on your phone. Cost of hosting and cloud connection is cheaper than ever before. So Amazon, Google have made it so cheap now. You can get this data streaming from your vessel as long as your internet connection for less than $100 per month per engine. So I don't think $100 to monitor an engine from remote is a big price to pay, but remote monitoring has to be the future. It is very viable, and it is another way that you can save a lot of money. Today, servers which are hosted on AWS platform, very cheap. We use analytics software like PostgreSQL and Cassandra. Real-time messages and email alerts can be generated very easily. We are doing that a lot in industry today. Reduces manpower at site as well. I'd just like to share with you, I think last month COI Review India, this is a magazine that looks at IoT, identified us as one of the 10 companies providing cutting-edge solutions in the IoT space, especially for enhancing predictive maintenance with innovative asset reliability management. So just a note to share you here. Ladies and gentlemen, that's the end of my webinar. Please contact us. You can view this in a couple of days on our YouTube channel. I'd leave this on the screen here for you, and you could follow me on my LinkedIn. There's a lot of articles that I keep putting up. My mission is to see how we could eliminate breakdowns and make maintenance simpler. I believe that there's always a better way to maintain your engines. Some questions here. Sir, can the TDC pickup be linked to the already existing pickup sensors? Yes, we can. If using CBM and retrofitting, we are able to increase TBO, will manufacturer accept it, and will the surveyor on board for inspection surveys accept it? So number one, like I said, it is in your interest to prove that you are using reliable systems. All classification rules, IX rules, have condition-based maintenance as an acceptable practice to replace it. They are still not sure because mind you, class is not a research organization. Essentially, they're here to see that you adhere to certain rules and conditions. Of course, classification societies like DNVGL, even LR to some extent, doing a lot of research work. But the answer to your question is yes, CBM is acceptable, will be acceptable, and it's up to you to work with class to make that happen. Will OEM concur or give in writing for time extension of overall base? So, will OEM agree to extending overalls? The answer is simple. Answer is no. Please understand that the OEM makes no money in selling you engines. The OEM makes money in selling you spare parts. So if you ask him 6,000 hours, he will say, okay, open it at 6,000 hours. The point is, the OE beyond warranty has really no say in how you maintain your engines. That is completely your call. I've got another question. Are torsional vibration measuring techniques the same as handy analyzers? Those measure common equipment. No, sir. Those handy analyzers are lateral vibrations, linear vibration measuring instruments. The only way that you can measure torsional vibrations is through speed sensors and, of course, the related software. So what you are talking of, handy analyzers are lateral vibration analyzers, not connected to torsional vibrations. Do these torsional vibration sensors need to be sent ashore for calibration at what interval? No, sir. Torsional vibration, as long as it gives you the right RPM, they don't need to be sent ashore for calibration. Basically, it's only a magnet inside the flywheel teeth cutting the flux, creating voltage, which is how they work. Very simple, not to be used. How to handle highly increased cleaning frequency of the lube oil filters with limited crew? Which are the... So, if you're talking of online filters, the whole process of cleaning it is literally a few minutes. It is outside, external to the engine, one wing nut on top, shut off valves, take an insert, put it back. So I don't think it is more than 4 or 5 minutes. And even if it takes some time to change it, just think of all the time that you're saving in overalls and repairing stuff. Also, consider the time that you're spending, that you're not spending in changing the oil, draining it, changing the oil filters installed on the engine. So really, it's should not be an issue. I've got torsional vibration monitoring is for engines only, or does it apply for pumps, purifiers? It applies to any rotating equipment. So it's not just pumps and... so like I said, we are using it on alternators. We are using it on motors. We are using it on gearboxes, large gearboxes. We are using it on rolling equipment. We are using it in steel mills. So anything that rotates can be measured. For getting a beta ratio of 800, what is the minimum number of passes of oil filtration that should happen in a day? Sir, beta ratio is the quality of the filter. It is not connected to the number of passes of oil filtration that should happen in a day. So beta ratio, like I explained in my seminar, very simply, if I have a filter, the quality of that filter will depend upon how much material will pass through. So suppose this is a 10 micron filter. How many particles of 10 micron or more can go through is the filtration efficiency. So if I say my beta ratio is 900, that means for every 900 particles of 10 microns or more, one particle will go through. That is the filtration efficiency. If I say that this is 200, that means out of every 200 particles of 10 microns or more, one particle will go through. So beta ratio is not related to number of oil filtration passes. It is simply the efficiency of filtration. What time interval do we need to change the filters in bypass? What will be the cost for change of filters? So cost is something, it depends on what brand, make you choose. Our experience is that in the first 3 or 4 months, while it is cleaning out all the rubbish in your system, maybe you need to change it frequently. But once the system has settled down, then filter changes also, intervals could increase 3 to 4 months between filter changes. So that really is dependent on what the system is. Somebody has asked me about beta systems, beta ratios again. Would you like to refer to my beta ratio blog, which I have posted on LinkedIn as well as on YouTube? So it will give you a fair idea of what beta ratios are. Any other questions here? Okay, I think that's it. So, ladies and gentlemen, thank you very much for your presence today. It's been a privilege to talk to you. Please do not hesitate to get in touch with me, get in touch with Neptunus. We are always here to assist you. The idea is collectively how we could save money, how we could use technology to increase mean time between overalls, and what we could do to save money reliably, not based on our intuitions or not based on our feelings, not leave it to individuals to decide, but depend solely on data. So let me summarize before I go. We talked about prudent spare part management. We talked about fuel. We talked about lube oil. I then introduced you to what I consider the most exciting technology in maintenance, which is what torsional vibrations is all about. And then we talked about remote access to your equipment. We answered a few questions. Once again, please do not exit your browser. Please end it by going to the bottom of your screen. I would love to have a feedback from you. Feedback is your valuable gift to me. It helps us to improve consistently, change our content matter, etc. This webinar will be available on the Neptunus YouTube channel. Thank you for joining. Namaskar. Jai Hind.